This is the Breville BCG400 dose control grinder. It was on, powered on, when suddenly it stopped working. And this is the fix on how to repair it. My problem was not documented on the Breville website. The Breville website had links if it's intermittently working, but this just slowly stopped. The problem was due to the switch had just suddenly failed. This was the temporary fix, but here I'm going to show how to conduct a permanent fix. Got that coffee everywhere. I called the company and they told me basically to go screw myself. That would be $80 to fix, and they would give me 25% off of a new one, which would be about $175 total after the deduction. And I said, no way. So I started opening it up, and I realized that it was indeed just the switch that had failed. So what you're going to need for this, very simple tools. You're going to need screwdrivers, including one extra long screwdriver to get the screws on the inside, and you're going to need a soldering iron, plus these replacement switches. Over here, this is what they look like. This is what the switch looks like, which I ordered from China, about 10 for $2. I will link the part number below, but it's just important that they have these two screws like this long lever arm. This is the switch that failed, the old one right from Breville. It's actually a Defond switch, which is quite good. This slight bend over here was my own error, and so was the solder marks from over there. I got it out quite fast in a hurry. And as you'll see, there are 3 contacts on this switch. There is common all the way over on the left, and then there is normally open and a normally closed contact. What that is are different modes for this switch to work. But we're going to want the normally open contact so that the motor doesn't run when the switch isn't pushed. Then when you push the switch, it will activate the normally open to be closed across the common, and that switches all 120 volts across the mains. This is the switch, the replacement switch that we bought from China. And over here it has three leads over here, so you're going to want to cut off the normally closed contact. So after you snip off the normally closed contact on the switch, ready to disassemble the grinder. All right, make sure you unplug the grinder before taking it apart. Make sure you save these screws separately. So now you can just pop off the bottom. There are no hidden screws, but be careful because of all the wiring underneath. So this may look super complicated, but in here is just the termination point for the cord. Turns out it's not actually grounded. They just tap the ground off over here on plastic, so that's great. And then what you're going to have to do is inside of here, you can ignore all of this wiring circuitry if it turns out that it was the same problem as me, and we just need to there are 4 screws down here that we need to undo so that we can separate the bottom from the top to remove this piece, which I've removed already, which houses the front panel button and the actual switch behind the button, which I've removed. So in order to do that, you need a long screwdriver. What's going on in here with which screws need to be removed. Now just go ahead and try to remove these screws. Some of them are very tight, but just want to undo them all the way, and this will allow us access to the front panel, which houses the switch, which we're going to replace. You do not need to remove the fasteners holding down the motor. I can't get it.
I see what you mean. Look at a long drive. Yeah. Got it.
Then Remove these last two screws. So now you can see that once you've removed all four of these screws, I've sort of left them in there for the time being, just sitting in those holes, but you can see that now there's separation between the top and the bottom. And I'm not exactly sure how to remove it completely, / I don't think it's totally necessary, so I'm not going to. But what we're going to do, I'm going to remove this temporary fix that I did last time. There are just two wires over here that when contacted together, when there's a circuit created, what it does is it then completely switches the power away from either the electronics or the motor. But this is actually switching 120 volts. And over here, this was a temporary switch until I had my permanent one, whereas this is the actual switch, or the actual button faceplate where the switch goes behind it and had the lead soldered to it. It looks like this, with this part going down into the switch. And then when the switch activates, it pushes on. When this button's pushed, it presses on the switch over here. As this switch is broken, so I soldered over here and it worked. What you can do is you can just sort of take your screwdriver, if you're not sure if that's your problem, and you can, when this is still in here, you can take your screwdriver when it's soldered still like this, when it doesn't work, and you can sort of just short the leads out across each other and see if it turns on. If it does, when it's plugged in, be very careful of that. When it does though, that means that your problem is indeed your switch and you need to replace it. At this stage over here, you wouldn't have this, and you would have the defective switch inside of the faceplate, and you can kind of separate this with your hand or with your screwdriver. There's enough flexibility now that we've removed the screws, and you can kind of just pull it out. You can see it's like notched over here, but I don't think it's necessary to disassemble the entire unit to get at that. So you'll just sort of pull this and it pops out. There'd be a screw fastening the old switch into the faceplate. You need to remove that screw, desolder the leads, and then you can just pull it out. Now we take in our new switch over here, test to make sure that it works, but just put it in here like this. Goes right where the old one went. Make sure that when you push the button and the switch actuates with the multimeter, that it actually makes the circuit. And then what we're going to do is, in a second, we're going to solder this back on. But we have our common and our normally open lead over here. And we're going to take this screw and put it back in. Perfect. So now I'm going to desolder the temporary switch that I had over here. If this was you, then this would be desoldering the broken Defond switch. And this one happens to be rated for more than the original switch was, but it's rated at 10 amps at 120 volts AC, whereas the old switch that used to be in the unit was rated at 6 amps 120 volts AC. Happens to be the new switch that we installed in this faceplate is rated for 5 amps at 120 volts, but I don't think it should make too much of a difference. So over here I'm gonna desolder the temporary switch that we had. It helps to get some fresh solder on the tip to conduct heat better even when desoldering an old part. So I'm just going to do that over here to get this heated up. Okay, that's one, and the other. Do a bit of the reach around method. There we go, so I've desoldered this, and now I just have to put on the new one. I'm not worrying too much about the heat shrink and the leads touching because they aren't too long. What I'm just going to do is I'm just going to feed them in. And for this switch, it doesn't really matter which side goes in. We just want to make sure that later on they don't touch each other. So I'm just going to try to fit those through the hole, and then pull this heat shrink that I had on from before to fit, and then just sort of heat everything back up. In order to make good contact, you need both the wire and the switch to be heated up in order for the solder to stick to it. So that's a fine job. Terrible job, but good enough. Reinstall the faceplate over here. So what we're going to do is just put this back in over here, and then I'm going to go from the top and sort of just pry it into the machine and try to lift up over here a little bit to help. And there we go, it just went right back in. Now what we're going to do is just screw all the contacts on the inside back in. We don't need to worry about the bottom yet. And I'm going to test it before sealing up these bottom 4 screws and really screwing everything down tight. Okay, so now that I've hand tightened up all these screws, not super tight, but just tight enough, I'm going to turn it right side up, plug it back in, and see if it still works. Give it a test. Fantastic. Should work like new. If it works at all, then it works fine if it was the switch. So, just like that, we've repaired it. But we do want to make sure that all of these screws connecting the top to the bottom are nice and tight, as tight as they go, just because there's a lot of vibrations going on from this motor, and you don't want that to loosen up any of these screws over time. After we've got everything all tightened up as far as we'll go, we want to make sure before putting it together that we route all of these wires into these slotted channels so that when we put the lid back on, it doesn't crush any of these wires. After aligning it, just goes back nicely. We can take these original screws from the bottom that we had over here and just tighten them back up. Okay, and that's it. Now it should work. You don't have to pay Breville $80 or $175 for a new one, and should be like new. And now I have 9 more backup switches just in case these ones break also.